Hello and welcome everyone for today's hands-on workshop on Ocean Node's VS Code extension and free compute data. Thank you all for joining the session. Today, together with my colleague Maria, we are going to guide you through this workshop and let you know and help you explore Ocean's protocol innovative tools and features. I'm Bogdan Fazakas, and I've been part of Ocean Protocol Core Tech team for over 4 years as a full-stack JavaScript engineer. Today's workshop is perfect for both Web2 and Web3 developers, AI beginners, data professionals who want a hands-on experience with decentralized compute workflows. This session will guide you through deploying and running algorithms using decentralized compute data directly between the Visual Studio Code IDE. Firstly, let's have a recap of what compute data is. So, compute data is a privacy-preserving framework that allows algorithms to run on sensitive datasets without exposing the raw data. This ensures data security while enabling insights and computation. With our new Adly free C2D feature, you can test, develop your algorithms without any cost, making it ideal for prototyping and learning. By integrating free C2D, developers can now experiment, iterate, and refine their algorithms without incurring any costs or compromising data privacy. Allow me to add more information about the free compute data and tell you how it actually works. It works pretty similar with the paid compute data. Your algorithm is running in an isolated environment inside an Ocean node with access to datasets. The raw data remains secure and never leaves its storage location, and only computational results are returned to you when the job is completed, ensuring privacy by this. The free compute data approach is ideal for scenarios like testing AI models on maybe sensitive healthcare or financial datasets, developing machine learning workflows in a secure environment, or even experimenting with decentralized compute solutions without any financial risk, because, as we said in the beginning, it's free. Let's talk about the Ocean Nodes VS Code extension and why should we all start using the extension. The Ocean Node VS Code extension eliminates the friction of switching between tools by integrating the entire C2D workflow in your favorite IDE. With the extension, you can do the following. You can write your algorithms, you can run the jobs with one click, you can monitor progress in real time, and even retrieve the results without any pain. In the beginning, before we are going to jump into the live demos, I'm going to try to walk you through the setup of Ocean Nodes VS Code extension. We are going to start by installing the Visual Studio Code. If you have it installed, please make sure that the version is higher than 1.96. Otherwise, if you don't have it, just go to this link that allows you to download the VS Code extension, the VS Code, sorry. I already have it downloaded, but for the sake of experiment, this is where the link is going to get you through. You will be able to download the Visual Studio Code for all available distributions. Either you're running on Linux, Windows, or Mac OS, you can download the installers for the Visual Studio Code. So I invite you all to download it and try to install it. This usually takes a couple of seconds, maybe a minute. So if you don't have the link or you are not able to write it down yet while I'm presenting it, just go to the Discord chat. I already pasted this link while starting the session. So while you all are trying to download and install the extension, I'm going to tell you what would be the next step. And this would be installing the Ocean Nodes VS Code extension on top of the Visual Studio Code. So once you have VS Code installed, you just need to open it and find the extensions section on the left side of the page, or you can use the shortcuts that I've written here, Control Shift X, or if you're on macOS, Command Shift X. If you can't find this section on the VS Code, you can also go to this link that it's also pasted on the Discord chat. That is going to redirect you to the extension page on the website for the on the marketplace with Visual Studio extensions, and you can just click install it. Otherwise, if you were able to open and find the extensions, just input here Ocean Protocol, and you will be able to find it. Just click install. Make sure that you tick this auto update option. This will allow you to be always up to date with the progress and the updates that the team is going to deliver, and you will benefit on the new features that the Visual Studio Code extension of Ocean Nodes will add. After you've successfully installed the extension, just go to the left side of the Visual Studio, and you'll be able to find it. So once it loads, you are going to see the Start Compute Job button and the Setup option. You can expand this, and you are going to see a lot of options that you can configure, or some of them will already be set up. So I'll move next to a short intro on the Visual Studio Code extension. As you can see, we have some required fields and some optional fields. I'll start with the required ones. The first one would be the node URL that already has a default option. You can either use our compute to data node, or you can update this option with your preferred node or node that you're running. The second one would be the results folder, where you can just specify a folder where the computation results will be saved once the compute job is finished. And of course, the algorithm files that you are supposed to be writing. As you see in my example here, I have opened a price average algorithm. You need to select that, and you will be able to start a job using that algorithm. Some optional configurations are the private key. This is your wallet private key for securing access. This is optional for free compute jobs. The Docker image and tags. This is used when you want to use a custom Docker image to define your algorithm execution environment. Or the datasets file. If you have a dataset published, you can select the file for that dataset. It can be either a CSV or a JSON file. On the center of the picture, you can see that this is the output of the Visual Studio Code extension for the Ocean Protocol. And in my case, this is a job that I started with that price average algorithm on some data sets from Dubai real estate. Okay, so with that being said, now we can complete the setup and explore the features. I hope by this time everyone was able to download the Visual Studio Code and install the extension. So it's time to dive into a live demonstration on how this works in practice using the experience that my colleague Maria will try to help. Maria will try to guide us through deploying an image processing algorithm step by step within Visual Studio Code. Maria will also showcase you how to monitor and the compute jobs and to retrieve the results. Some things that I've tried to share quickly, but he will go in depth with that. So with this being said, over to you, Maria. Let me stop the share screen and everything else. So you can.
Okay. Hello, everyone. Thank you, Bogdan, for the introduction. I am Maria. I'm part of Ocean Protocol core team member. I'm a backend developer. And for today's workshop, we prepared for you the image processing use case, which can be integrated within the VS Code extension and run on the free compute data stack. Let me share the screen with the algorithm. Okay. So this algorithm represents a good base to start with for the ones who are curious to discover how free compute data works integrated in the extension. We do support currently in the extension of the Python algorithms and also the JS algorithms. And I can guide you where you can find our sample algorithms in our public repos, and including the one that I'm sharing today. One second. And the code for image processing algorithm.
Sorry. So I think Maria lost connection. Give us 1 or 2 minutes so she can be back. I think it's internet connection issue or something like that. Just give us 1 or 2 minutes so we try to reconnect with her. Meanwhile, I'm going to try to answer the questions that you have so far on the chat. So I see a first question that is if Ocean Nodes VS Code extension is the extension name to search on the Visual Studio. Yes, you're right. You can just type Ocean Protocol and it will pop up, or Ocean Nodes, wherever it's more comfortable for you. Just go to the extensions and try to search for Ocean Nodes, for example, and it should pop up. Otherwise, you can just use the links that I shared above. I can share it again while Maria is reconnecting. I already see her live, so we will continue from where we left.
Sorry about that. My internet just dropped, so I will continue from where we were. Okay, so I was sharing the algorithm samples that we already have, and you can also browse into them to see exactly what it suits for you. for today, we choose the image processing, but you can also dive into the face detection, either in Py version. We do also have a JS version for this. The generating PDF reports as well based on stock market statistics. And now going back to our use case for today, let's talk a bit about the algorithm itself, the image processing algorithm itself. So it's quite simple and pretty straightforward, let's say. We do have one function which basically apply the filters on the provided image. For the free computer data version, the good thing, the advantage is that the data set is incorporated into the algorithm's code, so no need to publish a separate data set and after to link into the DID into the algorithm code. Right now, our data set represents the Lena image, which is in URL format here. Let me paste the link for you. To mention that the link you provide needs to be public, so the image should be public. This is the initial image of Lena. I think most of you know Lena because it's a, let's say, it's a famous image used for image processing task. So apply filters function receives as input parameters. What we need to provide to the function is the dataset URL, which is our image, and also the filter that that we want to apply on that specific image. So for today, at the moment, and bear with me at the end because we had a special quest for you as the community as well. For the moment, we have developed only the blur effect, the filter. So the outcome that, the expected outcome that we shall see of Lena image should look like this. So it's a very blurry image. And and I will show you how you can achieve this result based on free computed data image processing algorithm. Let me quickly delete the already compiled and the results before. Just one quick workaround here. Our data set, as I said, should be a public URL that we further downloaded with the requests library from Python, which is on dependency. We will open the image, and after, if the filter is selected to blur, we will apply the Gaussian blur, let's say, class from the pillow dependency that we'll use for image processing. The radius parameter here, it depends how the intense you want the blur effect on that image. Then we will settle the blurred image and return it. The return image will be saved in a data outputs file path. So we will see in our host computers at this path outputs and the filtered image name. And we will have also print which will notify us that the filters were applied correctly and the file will it's saved. Okay, so let's dive in the extension now. One second. Okay, that's the window for extension. So as Bogdan mentioned, the node URL is already pre-filled. This is our OPF node, which is hosted to run free compute jobs. The required fields that need to be added here are obviously the algorithm, which need to have the extension of JS or Python. the results folder, and after the Docker image and the Docker tag. Okay, let me pick the algorithm file. I have created a dedicated folder for image processing. Grab the file. The results folder also will be in image processing folder. I pre-completed this before, but I can do again with you. So Docker image has the role here to store the dependencies that we need to that the algorithm needs to have in order to run and execute its purpose, let's say. So as mentioned before, for image processing, we do need as dependencies request library, which allow us to download the image URL, and also the pil as pillow dependency to apply the filters and to manipulate the image as we want to do it. I will share the link to our public repo, which includes multiple Docker files along with the requirements. Along with the requirements, we have created for JS and Python 2 general Docker files that can be used by the community. One is PyGeneral, with which we will use today. And also we do have one for JS algorithms, which is called JS General, and has the Docker file for JS algorithms. I'll share the link of these for the ones who want to do the research further. Okay, going back to the setup, I'll write the Docker image first. And the Docker tag, I said that it's called PyGeneral. Okay, you can see that the selected algorithm pop-up, it's right at the top of the menu of the extension. And the results folder has been selected because it's showing the path here. Okay, now that we have those steps in place, we can start the compute job. And as the compute job started, you can see the logs in the output tab. The logs are passed from Ocean Node compute to data into the extension. And let's go one by one to explain what actually compute to data does here. So it assigns an ID to the job, which is a pretty long hash for security reasons. Then we have some phases from the job. You can see the life cycle of the compute job. First of all, you have the job started, and after the provisioning data step. Here, the provisioning data means that the requirements that I've talked earlier from the Docker file had been downloaded into the dedicated container for that algorithm. So basically the execution environment for that algorithm has been in place. Along in the provisioning data, when the environment is set up, the algorithm starts running. After that, we have the publishing results step, which basically means that the algorithm finishes its execution, and now you will be able to retrieve the results into your host computer, laptop, or whatever. And the job finished. What you see here in the text file is basically the final print that I have shown you previously in the algorithm, with filters applied and images saved successfully in the desired output. I'm talking about this print here. And now let's check the results and the format of the result. Okay, this is the folder that I said that it was used for storing the results. As I said, you have here the text format results, which shows the algorithm prints and console logs, which are also prompted in the extension in a separate tab. But you have also a copy downloaded on your host, a tar file, which is an archive containing the console logs and prints, and also the desired image that we want to showcase. So let's go into this folder with output extracted. As I said, the path should be outputs and the name of the filtered image as we specified in the file path. And now Lena from the beginning became the blurred Lena, as we expected. Now I would like to invite you to write together, let's say, two filters, and to test them against our pre-computed data within the VS Code extension. I'll paste the code here in the chat. This is the code that I also wanted for us to test, and then I can tackle the questions after. Okay. Let's go back into our file where the algorithm sits. Okay. So based off what I pasted, if we want to add more filters, here we have the if branch conditions where we can add the name of the filter and what the filter should perform and what classes from pillow dependency need to use in order to achieve that filter result. So for example, if we want to implement the grayscale filter, grayscale meaning that instead of initial image, which is colorful, as you may see, which has all three channels, so RGB, red, green, blue. For grayscale, we will have a single channel, which will show the image in black and white tones. In order to achieve that, let's write this code. So for this particular case, we want to set the filter parameter sent from apply filters function. We'll put here grayscale, and we will create a new object which will store the grayscaled image. So image convert, basically a function called convert L. Here L means that it's used for luminance. Luminance meaning that luminance mode, it means that it automatically converts the colored image into a single channel colored image, meaning in black and white tones. So grayscale, as we wanted to achieve. Filtered image in the end will be equal with the grayscale one. And after, in the end, the filtered image will be returned. Hopefully, you have managed to put the code into VS Code extension, and now we can also test this grayscale filter against Lena. So we'll need to modify the filter parameter from here into the grayscale in order to see if the expected data outcome will be a gray image. Okay, now we need to save the file. Just for cleanup, I will delete the previous results from the blurred use case. Okay, and now going back to the extension, we will do the same steps. So first, we'll need the updated image processing file, algorithm file. The result folder will remain the same, but you can select it again just for double check. And also the Docker image is the same. And I think I didn't paste that from the beginning. Let me put here the name to be easier to track. Okay. And then after you have all of this filled in, we can start the compute job. You can see here also the prompt, the lifecycle of the job, the same steps that we have seen in the output tab. You can see also as the pop-up notifications here. So again, it assigns an ID for the job started, provisioning data where the execution environment has been set up, and also the execution of the algorithm. Then job finished. We can see here the outputs from the algorithm prints as well. Now let's check the results folder. Going back to our previous location. So as you can see, the initial Lena right now became Grayscale Lena, as we wanted to achieve. I will delete this again because I want to implement one more filter for today. Of course, together with you guys. Okay, so if we want to define another filter, we will need to add another else if branch. So we'll give another name for the filter. For the moment, we want to use on unsharp, let's say. Unsharp filter. Again, unsharp means that the edges are kind of unsharped, as the name says, is very intuitive. It should look more or less like it will have like a cartoon lines in the end. I will demonstrate you in a second. Okay, so let's create the object which will store the unsharp image. And here, it's we will not use the convert function. We will use the image filter itself. So it's another syntax for especially for this filter. So apply the filter, which we'll retrieve from the library pillow. That's why it's very useful to use this kind of libraries here. So the filter is called unsharp mask. And again, you need to provide the radius, which means the intensity of the unsharpness that you want to apply to that image. Okay. Now, again, the filtered image, which will be returned, will have this value of unsharp image. And if we wanted to test this, again, we need to modify the filter parameter value from here, from grayscale, which was previously demonstrated. We will change into unsharp. Okay, save the file. And now going back to the extension. Let me clear these logs out. I think from the image processing, yes, we do not have the previous results. Just for clearness, we will select again the algorithm, which now contains the unsharp filter as well. Selecting algorithm pop-up in here, which means that we are good to go. Results folder, also we check the one from we will add the one from previously, image processing. Docker image and Docker tag remains the same. And now let's start the compute job. Again, the same phases, the same output consoles, which come from the Ocean node and parsed into the extension in order for you to see the life cycle of the algorithm execution. Now we received the log from the algorithm. We can also check the output image. Okay. And this is the unsharped image output as we wanted. You can modify the radius as much as you want, as much as you want to be intense. I set to 5 because it's like a default one. Okay. Hopefully you could also achieve these results together with me. If you don't, I will check also the chat in order to see if there are any problems. Okay, I see that Freeze tried to use the blur effect, so your output image is not blurred. You resolved it. Very, very good. Well done. That was pretty fast. Okay. I'm glad that you have solved it. Have you tried to add also those filter, grayscale, and unsharp? Any questions regarding those? Have you discovered any issues? Sami, yes, we will have a recorded version of today's workshop for you to tackle later as well. Okay, Freeze, I'm glad that for you it worked. If there are no other questions for today, we will share our recording as well. And if you have other questions, please feel free to drop here a message on the chat, and we will answer as fast as possible. For the moment, I will pause my share screen, and I'll wait for your questions if there are any. Thank you very much for your attention, and hopefully you enjoyed today's workshop.
Thank you all for joining. So feel free to drop questions. You can also raise your hand and ask them directly if you want to speak, not to write. You can ask questions related to the hands-on experience that you had with Maria, or with the things that we discussed in the beginning related to free compute or the extension itself. Anything that pops up into your mind, just feel free to ask, and we'll try to help. As I said in the beginning, thank you all for joining and doing this together with us. It looked like it was a productive session because we had participants that tried and have done the workshop together with us. So I think we'll do this more and more often. Yeah, if there are no more questions, we will end the session here. We have that the Dev Launch channel. You can all You can all join that channel and ask questions asynchronously. We will try to respond as quickly as possible. So feel free to join that and drop your questions when you bumped into them. Yep, Sammy, we will try to do this more often, and we commit to do this more often for sure. This is one of the targets for the next period.
And in addition to what Bogdan added, I suggest you to all, I encourage you to write your own algorithms or use our public samples that we have using the VS Code extension. And yeah, we are here for your assistance.
Okay, thank you all. We are going to close this. See you soon then with the following ups with and more workshops. Goodbye. Have a great day.
Goodbye. Have a good day ahead. Bye bye.